The first chapter is on geometry. The next chapter, that is, chapter 7, is on geometry. The first section is kind of an introduction to geometry, some geometric terms, and also how to solve some basic problems in geometry. A lot of it extending from Euclid's postulates. Anyway, geometry comes from the Greek word that means earth and measure. The Egyptians were also have a lot of history in just the basic geometry because they used to use different shapes to measure and survey land. I don't know if I'll get much chance to talk about that, but anyway, just a brief history. I'm going to go over some basic terms. The first one is a point is used to denote a location in space. A line is determined by two distinct points and extends to infinity in both directions. And a line segment is part of a line that extends between 2 points. Both of these kind of all are extensions of Euclid's 5 postulates, I might mention, which we probably won't have time to talk about, but that's kind of where the history comes from, going back to Euclid. And it's he actually wrote a book, and in that book it contained his 5 postulates, which basically define a point, a line, an angle, and things like that. And most of what you learn in high school geometry is based on that, and the existence of parallel lines, I might add. But that's stuff that we probably won't have time to go into. The next thing is the segment addition postulate. Basically says if a point B lies between points A and C, then basically AB plus BC equals AC. And that should be online. I happen to notice AC. Okay, so let's do an example that utilizes the segment addition postulate. So this first example is what we have is given that AB is 2x plus 3 and BC is 3x plus 7 and AC is 25. Find the values of x, AB, and BC. So the first thing we need to do is find x. So what we'll do is basically set up a formula. If we use the segment addition postulate, the segment AB plus segment BC will equal the entire length of AC. So what we can do is go 2x plus 3 plus 3x plus 7 is BC equals 25. And then we just solve this simple algebraic equation. On the left side, if we combine like terms, we'll get 5x, 2x plus 3x plus 10 is 25. Subtracting 10 from both sides now, if we isolate x, once we get it reduced down to 5x plus 10 is 25, we can basically play the game of isolating x and getting it by itself. So we would do the opposite of add 10, which is to subtract 10. That gives us 5x is 15. And then if we divide by 5, we'll get that x is equal to 3. And to get the original values, now we can just plug in. AB will be 2 times 3 plus 3, which will give you 6 plus 3 is 9. And then BC will be 3 times 3 plus 7, which comes out to 16. Notice 9 plus 16 is 25, so it does check. So that is the first solution to example 1. Here's a similar example, number 2. Given AB is 3x plus 5, BC is 2x plus 10, and AC is 45. Again, find the values x, a, b, and b, c. Well, if we set up the equation, 3x plus 5, again, doing segment addition postulate, if we take AB plus BC, it gives us AC, which is 45. Again, working the algebra, you're going to get 5x plus 15 is 45. We play this game of isolating x, so we have to do the opposite of adding 15, which is subtract 15. So 5x is 30. And if we solve that, opposite of timesing by 5 is divide by 5. That gives us that x is equal to 6. So AB will be 3 times 6 plus 5, which is going to be 18 and 5 is 23. And then BC should turn out to be 22. It is 2 times 6 plus 10, because the two have to add up to 45, which they do. So your answers are 22, 23, and then x is equal to 6. Just realized I was off the paper. So again, I'll give you a chance to write that down. X is equal to 6 when we're done, and then b is equal to 22. Okay, last example using segment addition postulate. This time we're dividing up into 3 segments, but we still can do it the same way. So AB will be 10, BC will be 2x plus 4, and then AD will be 36. Oh, excuse me, that is not right. CD is 12, but AD will be 36, but this little segment here is actually 12. So 10, 2x plus 4, and 12. And again, we can just do segment addition postulate. This add up the 3 segments should give you the entire length of the segment. So 10 plus 2x plus 4 plus 12 equals 36. So 2x plus 26, if we go 10, 4, and 12, equals 36. Taking away, again, 26 will give me 2x is 10. And then if we divide by 2, that's 5. And then BC would be, plugging in 5 for x, we get 2 times 5 plus 4. We'll get the BC is 14. And that works out that example 3. By the way, those are in the PowerPoint if you want to go back and rework them. The next video will focus on the same section, but it will deal with the topic of angles. So that's it for the segments. The next video is on angles.